Hello, everybody. In this video, I am going to discuss the static mechanism. As you know, we can have static variables. We can also have static methods. So I'm going to illustrate both of them in this video. First, let's create this Martian class. Okay, Martian. We are all interested in them, aren't we? Um, we How do you describe a Martian? Very difficult. We don't know what they look like. Let's just assume I'm just going to say color. They're not all red, hopefully. Um, so, and always remember that your instance variables are private, right? So private string color. And nothing else. If you can think of anything, that's great. Here, my purpose is to illustrate static, not how to write a class and how to analyze, design a class. Okay, just the static variable. So I will declare two variables. One is int count. Okay, so let's call this regular count. And another is a static variable, and I will call it static. Total count. How about that? Total count. Okay. So those are the two variables. They are both int, notice that, right? But one is static, one is non-static. And you remember a static variable apply to all the objects that are created. So let's write the constructor. Public Martian, and I will just say color is equal to red. And you can have, yeah, we can have another one, right? We can overload this constructor. But remember, your constructor's purpose is to initialize all instance variables. So I'm going to initialize this regular count, okay, plus, right? Let's do plus. And if we do that, we should initialize it to 0 here. And let's do that here too, okay? So initialize it to 0, and here we increment it. And here, total count, we increment it. So every time this constructor is called, regular count is at 1, and it's added 1. It's added 1. And total count has 1 added to it. So they're treated equally if you look at that, right? So I will just do this, okay? And just give it a color, okay? String color. And you also remember, since we have the same name, we use this to reference the instance variable, and this one without this to reference the parameter value, okay? So I'm not going to do the accessor and mutators here. We are not going to use them because of the purpose of this program. And you have plenty of that in the 3 videos in chapter 4. Okay, so I will just do a toString method, toString, and return, what do I return? Return the color, right? So color plus color. And plus total count. No, that's not important. I will just leave it there. Okay, toString. We always return a string. Okay, toString. Now, we will have 2 methods to differentiate them. Okay, one is public get regular count, get regular count. This is an accessor, right, for that count, regular count variable. Remember, your accessor always return the same type as your instance variable type. and it does not accept anything, empty parameter. You are just giving back the value. Okay, return regular count. And I will do another one, public int get static count. And for this one, it's also very easy. Return static, oh no, not static, total count. Okay, let me change that. Total count, right? Okay. So now let's analyze this. Let's think through this. Okay. Regular count is not a static variable. So when you call this method, you must create an object, right? So this is fine. Well, total count is a static variable. It exists as soon as this class is mentioned. So when you are dealing with a static variable, your method really should be static also, so that it's available as soon as the class name is referenced. Okay, so to deal with a static variable, you should use a static method. When you are only dealing with a static variable, you should use a static method. Okay. Now, let's see, instead of total count, can I do regular count? Think about it. Can I do regular count? Why does this not compile? You read the lecture notes, you already know this is because regular count is a non-static variable. A static method cannot do a non-static variable. It cannot access a non-static variable. Okay, so that's why we cannot do that, because a non-static variable does not exist when you reference the class name only. It exists when you create an object. Okay, so that's why. But you can access a static variable in a non-static method, right? So you can do that. Non-static method can access a static variable. Okay, so we got that out of the way. And now let's look at our driver. Okay. So I will create several little Martians. Okay, Martian M1 is equal to new Martian. Okay, I'm going to copy this. Let's create 3, and this will be called M2, and this is M3, and our Martian, this little Martian is of green color. Okay, so I will call those 2 methods, and let's see the difference, okay? I will say M1 dot get regular count, and I can copy. And this one is not the regular count, but we call the get total count. Okay, so that you can see the difference. Okay, I will copy those 2 here also, and copy them here also. Okay, so this way it clearly shows you what is going on. So this is M2, and this is M2, M3, M3. Okay, let's run. So you can see for M1, how about this? I'm going to make it very informative. Okay, so M1, regular count. Okay, and this one is M1, total count. I will copy those, copy that. And that should be M2. I will change it later. Oh no, not there. I meant to. So this would be total, right? I can do that here. And this would be total. And this would be M3 and M3, M2 and M2. Okay, let's run. And when you run, you can see for the first object, after it's created, the regular count is 1, the total count is 1. For M2, regular count is still 1, but total count now is 2. And M3, regular count is still 1, and total count is 3. What is going on there? Okay, when we call the regular count, okay, let's look at Martian. When we call the regular count is an instance variable. It's not static. So every time you call it, it's incremented by 1. It doesn't apply to all the objects. There are many copies of regular count as the number of objects. So if you have 10 objects, you have 10 copies of regular count. Versus the static total count. If you have 10 objects, you only have 1 copy of total count. So all the objects share this 1 copy. Okay, it applies to all of them. And that's why. So even here, even if you use M1, let's see, even if you use M1, it will give you exactly the same answer, right? It's still 3. Okay, so that's what that is. And that's it, right? I do not need to dwell on that anymore. Now here, let's do something else. Remember, getTotalCount is a static method, so we do not need to use the object, okay? We can simply do Martian, use the class name, and that's the proper way of calling a static method, actually. So you don't want to appear amateur, you want to be very professional. So for a static method, you simply call using the class name. So as soon as you mention the class name, that method is available. And it's available even here. Before you create anything, okay? No, let's do a system, okay? Before you create any objects, okay, total count. Let's do total count, right? Total count. And we can say Martian using the class name, total. Okay, let's run, and you can see it can compile. So, and you can see total count is 0, right? So that's what we meant when we say the static method is available as soon as the class name is mentioned. You do not need an object to use it, while an instance variable is only available when a class is created, an object is created, and the regular method can only be called using an object, while a static method can be called using the class name only. Okay? That's a contrast between a static variable and a non-static variable. And that's it, everybody.